All right, so y'all, first thing we need to learn before I do 9.1 is what we call interval notation. So this will be a review on interval notation. And really, this is just another way of writing our domains. So before, remember when we wrote domains, we had to put X and then the bar such that X is a real number and not equal to whatever. So interval notation. So the first thing we want to do, so to represent all real numbers, we use parentheses, negative infinity, comma, positive infinity, and then our parentheses. So anything from negative infinity to infinity in interval notation, that's how we represent all real numbers. Now, to exclude any values from the domain, we use the union. So that's what we call the union. And it just means and basically. So for example, to exclude any number A from the domain, all right, let me see what my chat's got going. Okay. All right, so if I want to exclude, say, a number A from my domain, we would write negative infinity up to our number A, close those parentheses, use our union, and then go from A to positive infinity. So we union around whatever number we're kicking out. Because when you use curved parentheses, that means it does not include that number. So you go all the way from negative infinity up to A, and then from the other side of A, all the way to positive infinity. And y'all, I'll show y'all that later on when we hit some examples. So remember, all real numbers is negative infinity to infinity. To kick out a number, we union around it. So let me get y'all started on 9.1. 9.1 is what we call composition of functions. So I'm gonna give you some symbolism here. So first we got F compose G of X. Now, that's not multiplication symbol. It's sort of like a degree symbol, but it's what we call a composition operator. And really what that means is you're going to put a function into another function. So it would be the same as find an F of G of X. Remember, order of operations, you would always start with the innermost parentheses. So we find G of X. Once we got G of X, we put it into the F of X. So here we go. We first find G of X. Then we put that into the f of x equation. Okay. The other symbolism, g compose f of x is the same as g of f of x. So when it's written this way, we first find f of x, then we put that into the g of x equation. So this is easier when they give me a number, because if they give me a number, I'll put that number in for my g equation. And then whatever answer I get goes into the f. Down here, if they give me a number, I put that into the f of x equation. And then that answer goes into my g. So it sounds scarier than they actually are, okay? So I'll start out doing examples where they give us numbers. And then starting around number 4, they're not going to give us any numbers anymore. So we'll have to put the whole function in there. So y'all let me get us started. So example 1, they're going to say that f of x equal negative 3x minus 1. G of x is going to equal x squared minus 2. They want us to find f compose g of negative 3. So we're sort of happy they gave us a negative 3. So this is like finding f of g of a negative 3. So I want to start from the innermost. I'm going to find g of negative 3 first. Once I find g of negative 3, that answer goes into the f. So here we go. First, find g of negative 3. All righty, y'all. So we know g of negative 3 is going to be my g equation, putting a negative 3 in for that x. So that's going to give me negative 3 squared minus 2. And y'all, I really can't stress enough, if you do this on that calculator, you got to put them negative numbers in parentheses. All righty, so let's work g of negative 3 first. So negative 3 squared, any number squared is positive. So that's going to give you a positive 9 minus 2, which gives me a 7. So since g of negative 3 equals 7, my second step is to find f of that 7. So it's like you get one answer and then put it into the other equation to get your final answer. So y'all, let's see, f of 7, I would take my f equation, which is negative 3, times x, which is 7, minus 1. All right, let's see what we get. Negative 3 and 7 give me a negative 21 minus the 1, which equals negative 22. So our final answer would be negative 22. So these are sort of like two-step equations. You just got to pay attention to what order they're giving you, okay? So remember, when it's written like this, negative 3 into the G, that answer into the S. And y'all, they're not too bad once you get used to these. So let me see. Number two, they're going to do a g of f. So it's going to be backwards from the first one. So for this one, they're giving me f of x equals 3x plus 4. G of x equals x squared minus 3x minus 5. So on this one, they're wanting us to find G compose f of 6. All right, y'all. So remember, this would be just like G of f of 6. So since I'm in the order of G compose f, that means the 6 goes into the f equation first. Once I find out what f of 6 is, I'll put that answer into the G. So first, we're going to find f of 6. Now let's see. F of 6 will equal my f equation 3 times x, which is 6, plus 4. All right, y'all, let's see what we get here. So make that curvy. So 3 times 6 is what, 18? Plus my 4. And 18 plus 4 gives us 22. So since f of 6 is 22, we now put 22 into the G equation. So I'm going to be finding G of 22. Ooh, look at that. I got 22 squared minus 3 times 22 minus 5. So since G equation had 2 x's, I had to put that 22 in twice. All right, y'all, big number. So let me see. I'm going to square that 22. That's going to give me 484. Minus 3 times 22 is 66. And then minus my 5. All right, y'all, so let's see what we get. 484 minus 66 minus 5 gives us a final answer of 413. All right, so you got to be careful how they start out. But remember, these are two-step problems. Find that second function, put it into that first one. All right, y'all, so next example. Let's see. So this one, they're giving us f of x equals 5x plus 4. G of x equals x to the third. They want me to find f compose G of a -3. So if I was writing this one out, it would be f of G of -3. So starting on the innermost, we're going to find G of -3 first. Take that answer, put it into my F. All right, so G of -3, G is x to the third. So that's going to give me -3 to the third power. All right, so what y'all getting on when I say -3 to the third power? Oh, that's pretty quick, -27. And that's a good job. I just wanted y'all to make sure, remember, negative numbers to odd exponents will stay negative, okay? All right, we got G of -3 was -27. So now we're going to put that into the F, which means we're going to find F of that -27. So let's see, here's my F equation, 5 times X, which was negative 27, plus 4. Oh, so let's see, 5 times negative 27 is giving me a negative 135 plus 4. So good job, you already got it. That looks like what? Negative 131. So good job, y'all, and that is our final answer. So y'all, I'll tell you the truth. To me, these aren't too bad when they give you numbers. But now they're going to change the game. So they sort of try to get a little tricky here. So on this one, look what they want. They want us to find F compose G of X, G compose F of X, and the domain of each. And remember, on domains now, they want these in interval notation. All righty, so I need an F. F of X is going to equal X plus 24. G of X is going to equal X minus 24. So they wanted to sort of start you out mellow on this, okay? And then they'll sort of turn it up as we go. So first I'm going to do the F of G of X and its domain. Then I'll do the G of F of X and its domain. So first I'm going to find F compose G of X. So y'all check this out. Remember, this is like F of G of X, okay? So that means I got to start with the G of X, and whatever answer I get from G of X is going to go into the F. So y'all, here's G of X, X minus 24. Because y'all guess what? They didn't give us a number this time. So we're not able to simplify this X minus 24. So since we cannot simplify that X minus 24, this whole thing has to go in for that X on the F equation. So that means you're finding F of an X minus 24. Okay, so that second function is going into the F. And since that's all going in for the F, we're really finding F of an X minus 24. So let's take our F equation, which is X plus 24. Replace this X with X minus 24 will give me X minus 24. And then at the end is a plus 24. So we still got a big X plus 24, except now my X is that whole function. So X minus 24 plus 24. Can you do anything to that to simplify that? All right, so Ariel said yes, so what are you doing? Okay, yeah. So these right here are definitely going to cancel. So since those numbers cancel, all that's left is our X final answer. So here's a question. So I'm doing the domain now for that one. So here's my F of G, my domain. Are we worried about anything on this domain? Because if you remember last week, there was only one thing I was worried about on my domains. So let me ask y'all this. Do y'all see any fractions? Oh, perfect. Negative infinity, positive infinity, because since we don't have any fractions to worry about, it'll go from negative infinity all the way to positive infinity. So good job. All right, so we'll have to move this down a little bit to see this next one. All right, so we just found f of g, so now let's find g of f of x. That's going to equal g of f of x. So remember, that will now be like finding g of my f of x equation, which is x plus 24. Right, I couldn't do nothing with the x plus 24, so that whole thing has to go into the x for the g equation. Woo, so let's see what that's going to give me. If I put x plus 24 in for that x, I get x plus 24, and then at the end is a minus 24. So y'all, what's that one simplify down to? Yeah, so once again, those are going to cancel, and all we get is our x. So that would be the final answer. Now, they're all not going to match like this, but this one did because it was adding 24 to this one and subtracting 24 from that one. All right, domain. Oh no, it takes y'all a while because y'all ain't got y'all a little infinity button on there. But remember, no fractions again. So once again, Tyler, that's going to be what? Negative infinity all the way to our positive infinity, okay? And y'all, it's going to be this every time if I do not have fractions, okay? All right, y'all, let's turn over. And now next one won't be quite like this one. So let's see. All right, so I'm going to do the same thing. I'm going to find f composed g of x, g composed f of x, and the domains. I'm going to start out with f composed g of x. So let's see on this one, f of x is x plus 2. G of x equals 3x squared minus 5x minus 2. So first, let's start with f of g. Remember, that is f of g of x, which means we're finding f of g of x, which is 3x squared minus 5x minus 2. All right, y'all, so let's take the f equation, which is x plus 2, and put in a 3x squared minus 5x minus 2 for its x. So that'll give me 3x squared minus 5x minus 2. And then at the end is a plus 2. All right, can we simplify this? Oh, I was hoping y'all would see one thing, 3x squared, let's see, minus 5x. Perfect, because good job, Peter, because once again, them numbers cancel out, and I get 3x squared minus 5x. So usually on these, once you get them substituted, It's just a matter of like getting rid of parentheses and then adding like terms. So how about the domain for that f of g? Oh, I can't tell if y'all are right or not on here. Okay, Greg, good job. Negative infinity, positive infinity. So no fractions once again. Now, y'all ain't gonna lie, the next one's more trickier because we're doing g of f of x. Remember, that's like g of f of x. So since g is my controlling equation, I put f of x in for its variable. F of x is an x plus 2. So we take the g, and wherever there's an x, we're going to put x plus 2. So we got 3 times x plus 2 squared minus 5 times x plus 2 minus 2. All right, y'all, order of operations means work inside the parentheses, but there's nothing I can do inside the parentheses. So exponent has next priority. So that x plus 2 is being squared. So I'm going to do some side work and take that x plus 2 squared. Now remember, when you got something like x plus 2 squared, you got to write it twice. And FOIL that, okay? So x times x is going to give us an x squared. X times 2 is a 2x. 2 times x is a 2x. And then 2 times 2 is a positive 4. And all I'm going to do to make that smaller is add like terms. So I get an x squared plus 4x plus 4. I'm now going to replace the x plus 2 squared with this. So bring down the 3. Put in our x squared plus 4x plus 4. And then I'm just going to bring the rest of it down. Minus 5 times x plus 2 minus my 2. So this went into that. Now what I'm going to do to get rid of parentheses, I'm going to distribute the 3 through the first ones, the negative 5 through the second ones, and then I'll bring down that negative 2. So 3 times x squared is 3x squared. 3 times 4x is 12x. 3 times that 4 is 12. Now remember, you got to distribute the negative through here also. So negative 5 times x is a negative 5x. Negative 5 times 2 is a negative 10. And then bring down your negative 2. So now y'all are going to add like terms. So we're going to bring down that 3x squared. Y'all, my x's will add together. We got 12x's minus 5x. That'll be 7x's. Oh, I think y'all got the answer already. So let's see, y'all got what? 3x squared plus 7x. So there's no numbers, right? Because guess what? That 12, that negative 10, and that negative 2, they cancel out. So that is our final answer. Oh, y'all rolling today? So let's see if y'all keep rolling. What is my domain? Oh, that's quick. Negative infinity, positive infinity. Good job. Okay, so now I'm going to tell y'all the truth. On the next one I do, we're going to have fractions, okay? All righty, so let's try the big one here. So we're going to find f compose g of x, g compose f of x, and the domains. All right, y'all, this time f of x is going to equal 3 over 1 minus 2x. My g of x is going to equal 1 over x. So let me start with f of g. So remember, that's like f of g of x, okay? Which means I'm going to be finding f of my g function, which is 1 over x. So when we put in this f, we're going to put a 1 over x in for that x. So that's going to be 3 divided by 1 minus 2 times 1 over x. Now, y'all tell you a trick. I'm going to be multiplying a number times a fraction. So I'm going to make the number look like a fraction because you multiply straight across for your first move, okay? So I'm going to simplify this. I'm going to have my 3 on top. That's going to be 1 minus, well, if you multiply straight across, top, you got 2 times 1, which is 2. The bottom, 1 times x. So here's the thing about this. You can't have what we call a complex fraction as a final answer. And a complex fraction is when you got a fraction inside of a fraction. So we're going to have to simplify this. So what you want to do to get rid of this fraction, notice that if I multiply by x, I can cancel those. But if I multiply one part of my fraction by x, I got to do it to everybody. So to get rid of this little fraction here, we're going to multiply all parts by x. So that'll give me my 3 on top times x, the 1 on bottom times x, minus 2 over x times x. So y'all, the main thing you notice right here, guess what happens? Those x's cancel. So what's left? 3 times x on top is 3x. On the bottom, I got 1 times x, which is x, minus that 2. So now this looks like a normal fraction. You got a numerator and a denominator. So that's our final answer. So I'll show y'all how I'm going to do this first domain, and then we'll play with the second one, okay? So the first thing, if I put a certain number into that bottom, that would make that undefined. So right here, x cannot equal what? It cannot equal a 0. Because if I put a 0 in here, 1 divided by 0 is undefined. So the first number I definitely got to kick out is a 0. Now, what about when you're down to this part? I got an x minus 2 sitting here. What number will I kick out of this domain so that that part don't equal 0? And there you go, a 2. Good job, Karen. So x cannot equal 0 because of this part. X cannot equal 2 because of this part. So for our domain, we're going to start at -infinity. And the first number you come across is 0. So watch what I'm going to do. So from -infinity, you go to 0. You're going to union around that 0. Sort of like I did with the a, remember? So you can go almost up to 0 is what the parentheses means. And then you start right after 0. So from 0, I can go to my next number, which was 2. So to kick out the 2, I union around that 2. So see y'all how I'm unioning here and unioning there? That's how you kick them numbers out. Now from 2, I didn't have no more restrictions. So from 2, I will then head towards my positive infinity. So for every number you kick out, you're going to have to union around that number, okay? So y'all not too bad. You just got to keep up. And these have to go in order from left to right. So remember, go in order from left to right. Okay. All right. So for our part B on that one, so let me write that in right here. For part B, we got to find G of F of X. So that's like G of F of X, which means we're going to find a G of whatever my F function was. So y'all are asking for fractions. There always be 3 domains. Only if you get parts where it makes it equal 0 in that denominator. So this one, I had 2 numbers out. So it was like you're unioning 3 little domains together. But y'all watch the next one. It'll only have 1 number, okay? All right, so we're finding G of a what? 3 divided by 1 minus 2x. Okay, so we put the whole F in for the G. Unless what? G was 1 divided by my X. And my X is going to be 3 divided by 1 minus 2x. So it still looks like my G equation, 1 divided by X. But remember, X is now that whole function. Now, y'all, this one, I can do different than the last one because I don't have like a little fraction inside of a fraction. So do y'all remember a rule for dividing fractions? We don't really divide fractions. We turn this into multiplication and flip the second one. So if you'll treat this like a fraction, say 1 divided by 1, treat it like a fraction, turn this division into multiplication, and then flip this fraction. So what that would give me would be 1 times, flip this fraction would give me 1 minus 2x over 3. So remember, change from division to multiplication. All right, when you do that, 1 times anything is going to be the anything. So this final answer will be 1 minus 2x over 3. It now looks like a normal fraction. So my final answer. So if y'all notice, the only place where I'm worried about a denominator is this x right here, because it's the only x in the denominator. Down here, this x is in the top, so I'm not worried about this one because the only thing in the bottom is that 3. So what we got to do is set 1 minus 2x equal to 0. Once we solve that, we'll know what the x we're going to kick out. All right, y'all, so let's what? Subtract 1 from both sides. I get negative 2x equals negative 1. Divide everybody by negative 2. So I get x. Remember, those negatives cancel. So good job. X is what? A 1/2. So 1/2 is the only number we're kicking out of our domain. So remember, it's going to start at what? Negative infinity. This time, since I only have 1 number, I'm going to union around that 1/2. And remember, so good job. You already got it. Let's see, carry negative infinity, 1/2, 1/2. There you go, positive infinity. So y'all, that was 9-1. So now we get to have fun with 9-2. All right, so we'll change papers. So for 9.2, we're going to look at inverse functions. So first we'll look at the inverse of a relationship or a relation. I'll tell you about the horizontal line test, sort of like the vertical line test, and then how to find your inverse function. So to find the inverse of a relation, we simply switch the x and y values for each point. Okay. So they're going to give us a set of ordered pairs. All we do is switch them around and we got our inverse. So watch this. Find the inverse of the relation. So y'all, let me see. They're giving me 4 points. They're giving me -9, 2, -7, 7. And remember, make sure you put commas in between each parenthesis. This one's a -2, 9. And then finally, this one is a 5, -5. All righty. So the answer so y'all say have plenty of time. I think the tests are all set up for like hour and a half. And my study guide will be 25 questions, but on the test, I actually only have 20 on my test, okay? But it'll be 20 out of the 25 from that study guide. And y'all ain't gonna get but one of each of these, okay? All righty, so let me start it out. The inverse of the relationship, it just says switch the x and y values for each point. So I'm just going to switch these points, and that'll give me what, a 2, -9. Switch the next one, I get a 7, -7. Next, I get a 9, -2. And then finally, I get a -5, 5. Yeah, I got this recording, y'all. So sometime today I'll be able to get this on YouTube for you, okay? So y'all watch this. Find an equation of the inverse relation. So this one they're giving us x cubed y equals -7. So for the answer, guess what? All I'm going to do is switch my x and my y. So if I switch the x and the y, I would have a y to the third x equals -7. Oh, cool. That was fast. So you got that, Tyler. Good job. Well, no, the tree was good because that gave me y cubed times x. Yeah, you're good. So once again, we just switch the x and the y. Okay. All right, y'all. So then you're going to have a few problems, what we call a horizontal line test. So we use the horizontal line test to tell if a function is what we call one-to-one. That means every y value can only have one x value. So one-to-one. Each y value can have only one x value. So if a horizontal line intersects a graph more than once, the graph is not one-to-one. Because when we find inverse functions, if the graph is not one-to-one, then it does not have an inverse function. Now, if I want to make the function work, I can restrict the domain by giving it a minimum value or a maximum value and restricting the domain to make it one-to-one. Okay. But I think they only do that on one, and I'll show you. So y'all, on this one, we're going to determine if one-to-one. Using the horizontal line test. So y'all, let me draw an X and a Y. So for this one, I'm going to have a line steadily increasing. And remember, horizontal lines go across it horizontally. So if I run this horizontal line down my graph, notice it's only intersecting it once. No matter where I get, it's only going to intersect it one time. So since it only intersects my graph one time anywhere, this would be a yes. So I ask y'all this, is that function one-to-one? Oh, good job. No, because right, if I run my horizontal line on it, it's intersected it on both sides. So y'all, good job. Now, let me ask you this. What if I restricted the domain? Whoops. So let me just put my hand there. So what if I restrict the domain? There's no x's that can be in the domain that are negative. Is this graph one-to-one? That's left. Yeah, so see, if I want to use a function like this, I can restrict the domain so that this part is actually a yes. Okay, good job. All right, y'all, so here's the fun part. We're now going to find inverse functions. So finding an inverse function. Because remember, those were all relationships I had a while ago, okay? So the first thing, function must be 1, 2, 1. And I'm going to tell y'all a little trick. From 7 on in the homework, they're all going to be 1-to-1, okay? So every one of those will be 1-to-1, and you'll have to find the inverse. So to find the inverse, we first replace f of x with y. So this will give me y equals some x, whatever. Next, remember when I did those relationships, I switched those x and y's around. So the same thing here, we switch the x and the y. So instead of saying y equals, it'll now say x equals something. Once we switch that x and y, we solve for the y. Now, when I solve for the y, my final step is to replace the y with f-1 of x. This is what we call inverse notation. Now, we don't have to solve it or anything. That's just letting me. So f of x is the function. f-1 of x is the inverse function, okay? And that's it, y'all. So let's play with a few of these. Let's see, 1, 2, 3. There's about 5 or 6 of these on the homework. So determine if 1-to-1 if 1-to-1, find its inverse. Now remember, y'all, all of these will be 1-to-1. So you might as well go straight on finding me those inverses, okay? So let's start out with this one. This one is at number 7. F of x equals x plus 2. So if you were to graph that, let's go to y equals, let me clear that out. And let me do x plus 2. So if you were to graph that, you get a straight line. So notice, you run that horizontal line down that. That is definitely 1-to-1 because it's only intersecting at once everywhere, okay? So it is 1-to-1. So remember, my first step, replace the f of x with a y. So replace f of x with a y. So that's going to give me y equals x plus 2. Next, I said switch those x and y. So now we're going to switch x and y. So y'all, if I switch to x and y, that'll give me x equals y plus 2. So now solve for y. And y'all, if you notice, there's only one step I got to do to get this y by itself, and that's take care of this plus 2. So what we're going to do, we'll subtract 2 from both sides. So I get an x minus 2 over here. That's going to equal my y. So I've got my y solved for, so now I'm going to replace y with f-1 of x. And at this point, what I'm going to do is I'm just going to put my f-1x on the left side. And that's going to equal my x minus 2. Now, MATLAB will give you this part. All you got to do is put in the actual inverse, okay? So if you notice something, if the function is adding 2, the inverse is usually subtracting that 2, okay? And y'all, these ain't too bad if you just follow these steps here, okay? Y'all ready for another one? Let's see. Let me try. All right, I'm going to do a tricky one here. It's like number 9. F of x equals 5 over x plus 9. So let's see, if we was to graph that, so let me see, 5 divided by x plus 9. So you notice it's a declining line that comes down. So it looks like we run that horizontal line, it's still going to pass. So it is definitely a yes. So since it's 1-to-1, I'm going to find the inverse. So first, I'm going to replace the f of x with a y. So y'all know to give us y equals 5 over x plus 9. Next, we're going to switch that x and y. So that's going to give me x equals 5 over y plus 9. So now we get to solve for the y. So I'm going to tell you all a trick. I don't like solving for my y when it's in the bottom of a fraction. So anytime I got a variable in the bottom, I multiply both sides by the bottom to clear the fraction. So to solve for y, I'm going to multiply both sides by y plus 9. And y'all watch what happens. So I'm going to do the y plus 9 times x equals my y plus 9 times my 5 over y plus 9. And remember, what you do to one side, you got to do to the other side when you got these equations. But the reason I did that is so I could cancel those out. So now I got my y plus 9 times x equals 5. Now, I'm going to tell you a trick. Most of the times, people want to distribute that x and get rid of parentheses, but that's doing too much for this. The easiest thing for this one now, divide both sides by the x, because the y is the variable I need to get over here by itself. So watch, if you come in and divide both sides by x, guess what? Those x's cancel. So all that's left is y plus 9. So since the y plus 9 is all that's left, do you think I need parentheses anymore? No, good job. So that's just going to be a y plus 9 equals my 5 divided by x. Oh, good job. Because all I got to do now is what? Subtract that 9. Good job, Valencia. That's good. So that gives me my y equals 5 over x minus my 9. So the y is now by itself. So my final step, replace it with my inverse notation. and I get a 5 over x minus 9. Y'all, that's probably the trickiest one, and it's just because of all the fractions they did to us, okay? All right, so remember, clear the fractions here. Now, you could have distributed it, and you would have got an answer that was like really similar to this, but it would have looked different, but it still would have took that method, okay? All right, let's see. Let's try this one. F of x equals x to the third minus 4. So let's see. Let's see what graph looks like. So x exponent 3 minus 4. So it should be a curvy line, but guess what? That curvy line is constantly going uphill. So once again, this would be, yes, a function 1 to 1. So replace the f of x with a y. All right, switch the x and y. So y'all, if we switch these, I get x equals y to the third minus 4. And y'all, let me tell you a trick. When you got a variable with an exponent, the easiest thing to do is get this variable by itself. So the first thing I would do to this is add 4 to both sides. So if we do that, let's see what that gives us. That'll give me what, an x plus 4. Those 4's cancel. So I get a y to the third. So how in the world can I turn this y cubed into just a y? Oh man, that's pretty good. Good job. A cube root. So really, whatever that exponent is what I would do to it. So good job. So we will take cube root of both sides. So the cube root of x plus 4 will equal the cube root of y to the third. Y'all guess what? A cube root cancels a cube. So all that's left over there is my y. Cannot do anything to that. So that's going to stay at cube root x plus 4. Well, that was a good job. That's the first one that answered that quick. And then finally, put it in my F inverse. So I get a cube root x plus 4. All right, y'all. So I got about 2 more to go. So I'm going to knock them out. So this one is f of x equals 3x squared plus 2. But y'all, then they're saying x is greater than or equal to 0. When they do this, they're restricting my domain, because look what happens. When I go to y equals, and I punch in my 3x squared plus 2. Notice when I graph it, I get a parabola. So the parabola is not 1 to 1. But right here, they're saying for x greater than or equal to 2. So that means we can only count the right half of the graph. And if you only count that right half of the graph, it's 1 to 1. So this is one where you have to restrict the domain to make it happen, okay? And that's what this means, is that the x has to be greater than 0. We're not looking at any negative x's. So not looking at any negative x's on the graph. Alrighty, so this is 1-to-1. So we're going to replace the f of x with a y. Now, since my x is being squared, I want to get that by itself. So first of all, I'm going to subtract 2 from both sides. So y'all, if we do that, I get a y minus 2 equals a 3x squared. Now, y'all, let me show you this one. This one, they give you most of the answer. So let's see. They're telling me the answer should be a square root with something on top divided by 3. What we got to find is what's going on the top of this one. So we know this is how the answer is going to be. So let's try to get to that. So now my next step, I want the x squared to be by itself. So we're going to divide by 3. So now divide by 3. When I do that, I get a y minus 2 over 3 equals the x squared. So here's my last question for this one. How do I turn an x squared into an x? And that would be good. Square root, so I'm going to square root both sides. So I get a square root of y minus 2 over 3 equals the square root of x squared. So remember, that radical cancels out that x squared, so that I end up with what? Y minus 2 over 3 equal to my... Y'all know what we did? Okay, so way back up here, we need to switch them. So I got all carried away. So remember, this should be an x and that should be a y, okay? So when we're done, we should get x minus 2 over 3 equals y. No, we were supposed to. I got carried away and was thinking I already flipped. And notice I was solving for the x, but it should have been a y there, okay? So y'all, we should flip these very first off the bat. So let me start that one over, because I don't want to mess y'all up. Or I could maybe say, hey, this was a test to see if y'all were going to make me flip it, right? All right, so here we go. Y equals 3x squared plus 2. Switch them. X equals 3y squared plus 2. And then do what we did the rest of the way, right? Subtract 2. Divide by 3. And then finally, y'all, take that square root. So it looks like I cannot do nothing to that. And then the square root of y squared is a y. So remember, they gave us this. All we had to do was come in and put in what? The x minus 2 on that, okay? All right, so y'all keep on the trail, because that's the first thing we got to do every time is flip it. But notice, once I flipped it, it pretty much worked out the same way. And are you noticing, when you start with x squareds, you end up with square roots. When you started up with a x cubed, you ended up with cube roots. So the functions always sort of make sense when you're done. So let's do one more. Let's try this. F of x equals the square root x minus 3. So pretend like we graphed it. It's 1 to 1. So we're going to replace f of x with a y. So y equals square root x minus 3. Next step. Switch them, right? There we go. Switch x and y. So we get x equals the square root of y minus 3. So y'all, I got a situation here. I got a y minus 3 under this square root. How can I get rid of a square root? So y'all, let me tell y'all. Oh, perfect. Square it. I'm going to square both sides. So you use exponents to get rid of radicals. You use radicals to get rid of exponents. So they go back and forth. So we're going to square both sides. So that's going to give me an x squared equals my square root of y minus 3 squared. So you can't do nothing with that. So that x squared comes down. But this radical cancels with the exponent, leaving me a y minus 3. Last move, y'all. So what are we going to do right here? Get that y by itself. We want to add our 3 to both sides. Oh, I think you done got the final answer up there. So you added 3, it looks like. So there you go. You get an x squared plus 3 equals the y. Good job. And then I'm just going to turn that into f inverse and put in an x squared plus 3. It's sort of tricky for y'all having to write all these on that chat, right? With the exponents and all that fun stuff we're doing. All righty, y'all. So let's see. There. All right, so I'm gonna stop my share. Whew, so questions on that. Now remember, I'm gonna be sending this video out later for y'all. That way you'll have it to sort of go by and use for help. So I'm trying to see, did I get any questions here? And y'all, that's all we got this week is 9-1 and 9-2. What we did today is the only assignments for the week. We'll come back next Monday and pick up. And next Monday, we'll start solving systems of equations. So y'all got to chat. When's our first test? So this week was 9-1, 9-2. Next week will be 3-5, 3-6, and 3-7. They're all doing systems of equations. After next week, the next Monday, I'll open test 1. So our Monday, what we'll do is we're going to review test 1, the study guide that counts as a quiz for y'all. We'll knock that out. And then you'll have till the next Sunday to get your test done. So I'll leave that test open from Monday till Sunday night for y'all. So let me see, when is that date? That'll be so test 1 for y'all will basically open up on September the 19th. And it'll be due September 25th. Okay. All righty, y'all. Let me see. I'm not looking I'm not seeing any other questions on there. And y'all, we'll study really good that Monday for that test, okay? All right, so I'm gonna stop my recording because I don't see any more things.